Alright guys, so we'll continue with the failover cluster configuration. Basically we want to check out the SQL Server high availability or SQL database high availability when there is failover clustering involved. You have seen that failover clustering in the background working for the Exchange Server databases. So that was DAG, database availability group. So that is something that we want to achieve here in SQL Server as well, although SQL Server has even more features of high availability. So we had started to configure the environment of SQL Server, and we had gone to, if I just go down to the lab stats, so we had created the two virtual machines there. So I'll just go to this. Okay, so yeah, so there were those diagrams that I have created there, and we had reached until where we have configured the failover clustering networking portion of that. So I'm just gonna click that. Okay, so I'll copy that to put it on. So the main purpose of SQL Server failover clustering, if suppose the SQL Server database is connecting from server 2, which is currently active server, and server 3, which is currently passive, then active SQL Server 2, if that server actually crashes, so in that case the SQL Server database should just be available from server 3, or well, when it crashes, so the passive obviously becomes active, and the new active, and the other server is down, right? So this active is down, and it will become the new active, and the database should be available from this other SQL server. Now for that we need to actually make sure that the SQL server, the underlying structure of SQL server is good, and that's why we created the rest of the machines there. It is in fact 4 and 5 machines, and if I go down to the other diagram, I'll copy it somewhere else, and then copy back here. Okay, so this is the whole structure here. Server 1, Active Directory, and DHCP. So we have all this, and we've logged in from domain admin from all machines. We have server 4 and server 5 created there, and we gave the IP addresses 4 and 5 respectively to the next machines. We need to basically install here underlying so over the OS, on top of the operating system, the FC has to be there, failover clustering, and this is where we have to really configure step by step the failover clustering. and not like in Exchange Server where there was DAG or database availability group, and it was just configured in the background. We just had to introduce the DAG, and it was configured in the background. Okay, so now this FC or failover clustering is there, and on top of that, then we need to install SQL, and SQL will be detecting that below it is the failover cluster was in a configured, and then the SQL Server on top will be configured on both, and then it can use the failover cluster feature, underlying failover cluster feature there, right? So that the main plan is, or the major steps are that we have already created the server 4, server 5, and it is joined to the domain as well. What we were doing was configuration of the failover clustering, and in the failover clustering we have also different stages there. So we have to configure networking of failover clustering, then we have to configure storage of failover clustering, and then finally, when they are carefully configured, then we can install the actual failover cluster role. Actually, it's a feature, so you need to install the actual failover cluster feature, and then we can in fact try to check that if they switch over or not. So switch over, normally they call it also, suppose you intentionally switch the active from server 4 to server 5, so that is normally considered as switchover, but it is called failover there as well. Normally failover is when any device fails, or the active one fails, whichever is active between server 4 or 5, and then it just, the services on the top of the active automatically transfers to the passive one, making passive the active. So we need to go through all these stages there, and we were in the process in the last class of SQL Server. We were in the process of installing. We installed the server 4.5, joined the domain, logged in from SQL admin, and we had actually started configuring initially the failover clustering, and the networking portion or section of the failover clustering was configured. So if I just refer back to this diagram, then now the names obviously are, server 1 is server 1, but this is not 2, and this is obviously not 4. These guys are 3, this is not 3, and these guys are 4 and 5. Okay, so we had actually added here, so this line we can ignore that, or well, I'll just get rid of it quickly. Wow, serious. Okay, so here we had added one network card each, one extra network card. So first network card is for the purpose of LAN communication, and the other network card is for the purpose of heartbeat and HB, right? So this HB network card was added, one each on server 4 and 5, and the main purpose of heartbeat network cards is to send I'm alive packets per second. So they just keep on telling each other, hey, I'm alive, I'm alive, I'm alive, I'm alive, right? So if there's 5-second or 5 packets are missed, then if 5 packets are missed, then passive assumes that active server is gone. So if that much packets are missed, then simply failover happens, right? So if 5 packets are missed, then passive assumes that active server is gone, and failover happens. Failover happens, right? So this is already done. We're gonna just double check that now, that if the network cards have been added, and we have also labeled them, the first one LAN for both machines, and second one as the HB for both machines. Then we had to go inside and in fact disable the DNS as well. Not only that, but we had put those network cards on separate VMnet. You can totally put them on separate network, these two network cards, while these first network cards of both can be on a separate network, which is actually the LAN, where they are communicating with the first server and the rest of the environment. They are all communicating with that, right? So the first network could be different, and the second network could be from another. You can just put another physical switch in a production environment for the other two network cards. So that's just the heartbeat communication going on between the two servers, and so we're gonna check out that how it is done here. So I'll just quickly put the machines back so we could check. So here I'll just start the SQL Server 1, and then 4 and 5 as well. So while 1 is starting, and that's the authorization machine, the domain controller. So normally it should start and logged in fully, and then the other machines are supposed to be started, but those other are actually put on suspension. So when they are unsuspended, they will expect the server 1 or the domain controller to be in the environment already. Now, while this is starting, I'll just go for the diagram, and what we need to do next is, now the networking portion is done, that we have to put heartbeat network cards, and we have to configure them in a way that they don't disrupt the local area network traffic, the DNS, the DHCP, the SQL Server traffic. They don't disrupt that, right? That's one thing. And I'm going to double check that if the two network cards are there and they have been renamed properly. Also, we gave the IP address totally different. This is 10.0.0.1 and this is 10.0.0.2, while our LAN network card IP address scheme is 192.168.200.4 and 5. So the IP addresses are different. There should be physical switch should be different. So all that is necessary for the heartbeat traffic to not disrupt the regular traffic of your network. So I'm just going to log in from my domain controller, and while it is logged in, so I'm just going to go for the server 4 here. Server 4. So it says oh yeah, I had actually moved it, so yeah, I'll just move from here. So 5. Okay, so I'll just start, and server 4 is also here, so I'll start that too. Okay, so server 1, and it's just asking for updates, so I'll just click that, and I'll update that, and I'll drag server 5 here, so over here. So now what we need to check first is that the network card settings for the OS is good. Also, other than that, I'll just go for whoami command. So I'm going to open the command prompt in all three and go for the whoami command, so we could see that what username and what domain is being placed here. Actually, they're still loading, so Yes, so so it's SQL domain / SQL Armor SQL admin, and here also it's waiting. Okay. So it should not be logged in from local administrator from any one of those. Otherwise, the whole failover clustering process will be affected by that. Won't go ahead. So we're just logging from the correct credentials. Second thing, the server 3 should have 2 network cards. So I'm just gonna check on, well, it's server 3. Sorry, server 4 should have 2 network cards, and server 5 should have 2 network cards for failover clustering. The underlying failover clustering before we install the SQL server. So if I go there to HB and LAN, actually it shows here as well. So in the local server, I'll go to the LAN, and there's LAN and HB here. If I go to the other one and local and click that, so there's LAN and HB showing here as well. So that's okay, that's good. And as far as the networking is concerned, there's IPv6 enabled here. So for the LAN, so I'll just double click that, and properties. If it is still enabled, it doesn't really make a big difference. When we are troubleshooting, so when we need to ping, so IPv6 address comes back, we're not so used to seeing this. I'm just going to press OK and close. So as far as the networking configuration is concerned, so 2 network cards are there, and the IP addresses, proper IP addressing is given there. If I am on server 4, I'll double click that and go to details here, and it shows there's 10.0.0.1. If I go to server 5, go to double click, and details here as well, so it's 10.0.0.2. So 10.0.0.1 on 4 and 10.0.0.2 on 5. So we're good. And networking side is done. Now we need to actually go for software SAN configuration, and we need to deploy. Failover clustering cannot be configured without software SAN. So for that, we need to now prepare the whole environment, and what we can say here is that actually we had some screenshots in the last class for the failover networking. Oh yeah, the LAN and HB was configured on both server 4 and server 5. So yeah, that screenshot was taken. So what we can, so we will continue with the failover cluster configuration for our SQL Server 2016. Okay, so since screenshots were already taken for the networking, so we're going to go for the storage and what to do in the storage. So for the storage, what we need to do is we need to have some kind of SAN device there, so where we can just put some disks and then convert them to Iscsi to be shared over the network as LUNs or logical unit numbers, right? So what am I talking about? So first of all, this is networking, and second thing we need to configure is storage, and that storage has to be in such a way that it's just available from over the network, right? So what I mean by this is that we're going to be creating first of all, it's a software SAN, and that we're going to go for software SAN. And SAN we may have talked about is storage area network. And the purpose of SAN is to it provides storage or disks over the network to other machines, and over the network it provides disks to and machines. We can also call it shared disks, or lons, and the name is then logical unit number. It is in storage terms it is called lons, and these are just shared disks over the network, right? So normally the storage solutions or the SAN solutions are really expensive in production environment, and the environment, if the environment wants to go for SAN, so normally there are storage area or SAN solutions need to be purchased, which are really expensive. And suppose I go for HP SAN, so Hewlett Packard SAN, and images. So normally it's just rows and rows of disks that are available, and obviously that's why it's expensive as well. So these are all disks after disks after disks, and over the network they are so obviously first of all it's expensive, and second thing is the disks are really fast. They are highly available as well, and you can just put here terabytes of disks, and you can have more machines there, more towers there as well, with which will have rows and rows of disks. So what happens is that you get that, suppose you get a SAN here, SAN solution. So that SAN solution, you can just attach disks or map over the network the disks from here to the server. So suppose this server 4 actually needs 200 disks or 300 disks, right? So we cannot possibly physically put 300 disks there, but over the network we can map those disks or share disks over the network or lons here, right? So each one disk, so one disk is shared with two. Let me just create that diagram in that way. So that one disk is shared with two machines, and then the second disk, so each disk is shared with all the machines. So this means that if the data of the disk, if the machine goes down, right? So what's the main purpose of sharing one disk to two machines or 200 machines, each disk to 200 machines? That if you have some user connected from here, server 4, and put some data here. Now the user is working on that data and saving the data as well, suppose. So what happens is if the server 4 goes down, it crashes. So that same disk is connected here to server 4, and that same disk is connected to server 5 as well. So in that case, the data of the user is not lost. The user may be temporarily disconnected if it is configured with failover clustering. So the data will be available from here. The user connection will be redirected from server 5, and it will be redirected to the same disk and data. So user will not lose access to the data, and while the full server has crashed in the background, and user might see a few seconds of frozen screen, click 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 click, and nothing happened, and all of a sudden everything is okay, while in the background the full server has crashed. So because of the SAN, this is then easy to make the data highly available. And in our case, what we intend to do is we need to create a database. I was just talking about data, but what about if we create our DB01 on top of this shared disk or LON, right? So this database is being accessed by everyone from this server 4, right? And this database is created on top of a LON that is actually coming from, or the shared disk that is actually coming from SAN. So if this server goes down, so all connectivity over the network that was coming through server 4, that connectivity will be at once in seconds will be transferred to through server 5, while the disk is also already mapped to server 5. So all end users will be connecting to the same database from actually server 5 instead of 4, while because 4 just went down. So services failover right away in failover clustering, and whatever data was there over the network, so it was not on a local disk. This database was not on a local physical disk. It was on a LON or a shared disk. so that data will be available. If it was on the local disk, obviously, then that data will also be, that database will also be not available, right? So that's why SAN is so crucial if you want to have high availability. This disk is connected with server 4, this disk is also connected with server 5, and if connections were there, were made over the network, and users were connecting through server 4 to the database, and server 4 goes down, so all connections redirected through server 5 while the disk was already mapped to server 5. So the database will, same disk is connected to server 5, so same database will be accessible from server 5. Failover clustering just arranges the redirection of connections and reconnection as well. It's kind of not reconnection, they're just connected. Users don't feel that they were disconnected and then connected. They just see that they're just connected. So everything has to move to the other side in seconds. So this whole thing needs to be achieved. So obviously we have configured the networking portion of that, which the failover clustering will detect, because there will be a test that it runs a test on its current configuration, and then it lets us install the failover clustering. So it's gonna check every nick and corner of the two machines if they are connected and configured correctly. So the networking portion is done. For the storage, we need to have a software SAN. Now we cannot purchase a, like this could be a $50,000, $80,000, $100,000 solution, and or even much more than that, because big companies then go for hundreds or thousands of disks there to be made available for their machines. So if that is not available obviously for us, so we're gonna make this server 1 as our storage solution. So I'll just grab this diagram again, because we need to further work on this. So this was just for explanation that why this software SAN is so important, because it's gonna make our data highly available. In our case, because it's SQL, so it's gonna make our database highly available. So in this diagram, where I explained before that we will have a software SAN, and showed you a picture of an actual hardware SAN, which is very expensive. So we will have a software SAN, right? So how can we have that? Well, first of all, that we need a machine for that. So server 1 is there. Second thing, what we're gonna do, what our plan is, that we're gonna add 3 disks here. We're gonna format them with locally with NTFS. So once these 3 disks are created or added to server 1, we're gonna format them one by one, and then we're going to convert them to Iscsi disks. So convert to Iscsi. When we convert to Iscsi, the main benefit here is that once, if they are formatted with NTFS, right, just like any disk added to Windows machine, so yeah, you can use that disk locally. But if you want to share that disk over the network, then you have to convert it to Iscsi disk. Iscsi is a storage protocol with which you can share any storage over the network on Ethernet network to other machines. So convert to Iscsi, we will be able to share these disks to other VMs over the network, right? So that's the main benefit of, or advantage of, converting to Iscsi disks, because you can share each disk over there. So it's not a shared folder, it's the whole disk itself being available, mapped over the network to these servers. So what will happen is, once we convert to Iscsi, we're gonna actually map it to this disk will be mapped to server 4, and this same disk will be mapped also to server 5 again. Okay. Okay, so these disks will be mapped to, this one disk will be mapped to server 4 and 5, and it will be called a shared disk or LON, and this will be LON01. And then we can also go for the second disk. It will be shared to this one disk will be shared to both machines as well, and then this one disk will be shared with both machines as well. So the same disk must be shared. Why? Because the data that has been saved from through the server 4, so remotely somebody connected and saved the data here. So if that server 4 goes down, that same disk or LAN over the network is attached to this one as well, so data can be accessible from here as well. So that's the logic of having the SAN and high availability of data with the virtual machine. So whenever the users connect, they always have access to the data. Okay, Khalid says privately, or you can. Okay, so Iscsi equals we will be able to share these disks to other VMs over the network. Yes, exactly, Khalid. Exactly, you're right. So with Iscsi, we will be able to share these disks over the network. Suppose you remove the Iscsi option, then they are just simply local disks. Only with Iscsi. So there is fiber channel protocol, fiber channel on our network, or FCOE, and then there is Iscsi. So fiber channel, if you have fiber optics cable there, if you have fiber optics switch, then that's the other choice. So we have their fiber optics cables for SAN, right? So either so that's why it's really expensive, because the companies go for these fiber optics cable that they connect to SAN, and obviously these are really the speed is really good, the bandwidth is huge when fiber optics is there, and that's why it becomes really expensive, 80,000, 100,000 solution, because all the SAN switches. So this full SAN tower would be connected to fiber optics cable, and then there would be fiber optic switch here as well. So switch, right? So and obviously then there will be fiber optic network cards there as well. So those network cards can actually connect. So these are switches, and then on the other side of the machines you will have fiber optic network cards. So the whole fiber optic equipment you need to purchase, and that's very expensive, but it's really speedy, and a huge bandwidth is available all the time, and less data drop and data corruption there. So that's why fiber optic equipment is used. But suppose the companies, not all companies cannot simply afford this kind of equipment, so then the other protocol that was developed is Iscsi, that you can work over Ethernet. Now fiber optics also shares, the concept is exactly the same, it's just that the equipment is much better and very expensive. In Iscsi, the disks can be shared over the Ethernet network. So yes, now your Ethernet network can be, you can just put the cables there, like if you know the types there, Cat5, Cat6e, those cables. So those are, obviously every company can afford that, but the disks can be shared over there. Obviously it's going to be slower then, but the main thing is that you still are able to share your local disks, so one machine over the network to other machines as well, with the help of Iscsi protocol, which actually shares the disks over Ethernet network, the one that we are using right now in colleges and small companies, or in big companies as well. Normally the Ethernet cable is there, and fiber optics is just coming for the backbone network, like from the server side, IBM, Dell servers, to the SAN storage. So your local machines, they always have Ethernet cables. Okay, so we get that. Okay, we're gonna go to server 1 for storage. For the failover clustering storage, we need to configure a software SAN. And that software SAN, for that, we're gonna go for server 1. Server 1 is just doing Active Directory, DNS, DHCP, so that doesn't take a lot of CPU and RAM. So we can use this server as software SAN as well. What we're going to do is we're going to add 3 disks here. We can give any size because they are dynamically expanding or thin provisioned. So we can go for 400 GB size for each disk. It doesn't take that much size actually because it's thin provision. So it depends on how much data is inside, and not much data will be there obviously. So 400 GB each disk we're gonna add on server 1 by 1, and then we're gonna format them 1 by 1 as well. And then we're gonna install a feature in Windows called Iscsi, and then we're going to convert each disk 1 by 1 to Iscsi disks, and after that you will be able to map those disks to first disk you will map to server 4, 5, then second disk you will map to server 4, 5, and then third disk you will map to server 4 and 5. So we're going to go through this whole process, and then we're going to make sure that the storage devices are connected. Once they are connected, so we'll try to then further do the configuration that is required here. Once the networking is already done, right? So once the storage is done, then the third stage is actually the failover clustering feature installation. So I'll just go for storage. So let's do that. I'm going to go for server 1 and add the 3 disks 1 by 1, 400 GB each, and then convert them to Iscsi. So this needs to be done. Now there is another terminology for storage. Obviously in SQL Server, SQL servers are, you will see always they are configured with high availability options there. So another terminology in the software SAN or SAN is that there is always a target, and there always are initiators. So what does target do and what does initiators do? So that should be simply understood here, that target offers the storage over the network, right? And initiators requests the storage over the network. So that is target and initiators. You're going to see that terminology now being used to offer the disks from one server to another. So this is our storage setup here, and we need to configure. So first we're going to configure the target side, that is offering the disk here. Then we're going to go to the initiator side. So target is server 1 obviously, because it's going to offer the 3 disks over the network. Initiators are server 4 and server 5, which will be requesting the disks over the network. So obviously all the communication has to be good between the 3 machines, otherwise it's not going to show up there, the disks. So guys, this will be our screenshot number 1, and screenshot number 1 is software SAN for FC. So take a screenshot number 1, software SAN for FC or failover clustering. Software SAN for FC is the title. So take screenshot number 1 here. I'll take the sample screenshot now. Software SAN over FC. For FC, sorry, it's not over. Software SAN for FC or failover clustering. So I'll simply put that there. So screenshot 1. Software SAN for FC failover clustering. I'll put the screenshot here, and it's now software SAN for FC. Okay, so the screenshot is this diagram. So that's our screenshot number 1. This diagram is our screenshot number 1, and software SAN or for FC. So let's go ahead and configure that and then we're going to test the failing over process of that as well, and then we're going to go for the next one, which is installing the actual failover cluster. And after that we will install SQL servers on both, and we'll try to do the crash test finally, that if we crash one server, does the database still stays available or not. So that's our first screenshot, and let's get going. I'm just gonna go for server 1 here, and we're gonna set up the whole configuration on server 1. So I'm in server 1 here, and in server 1 we already have if I go for the file explorer here within server 1, so we have one disk here, local disk. Obviously we're not going to touch that because it has the operating system here, right? So I'm just going to go ahead and go up to the server 1, and I'm going to add 3 disks, 400 GB each, and then format them locally, and then convert them to Iscsi. So the target could offer these disks over the network. Target offers the storage. So I'm going to right click here on server 1 and go to settings. Here it's VMware 15, yes, and I can see that there's one disk, 200 GB, so we're going to add 3 more. I'm going to click add, and hard disk is already selected. I'll click next, SCSI, next, create a new virtual disk. So nothing changed, just the hard disk was selected, and I clicked next. And then there is that 400 written there. So this much size will be there, but since it is thin provision, so we don't have to worry about that it's going to take any size on the physical disk, because whatever software we install, it just takes that much size. So I'll just click the single file here. Whether single file or multiple files doesn't really matter here. What I'm not going to click is this allocate all disk space now, which means that it's going to become thick provision. It's going to occupy all that disk space that you mentioned here. So if you keep it unchecked, then it will be thin provision. So I'm just going to click next here, and that's the outside name of the disk. So I'm going to click finish, and then I'm going to click add here, and the hard disk. So I'm going to click next here as well, and I'm setting the second disk, so it's the same thing all over. SCSI is okay, next. Create new virtual disk is okay, next. 400 and single file, that's okay, next. And the outside name of the disk, which we don't need to change, so I'll click finish. The 2 disks are added. We'll go for third as well. Now one of them will be a quorum disk that we have discussed in Exchange server as well, the concept of quorum. I'll just refresh it here as well briefly. So the hard disk is here, and I'll click next, and then there's SCSI, and then there is next again, and next. So 400 GB and single disk. I'll click next. So here I'll go for finish. Okay, so 3 disks are added here, and we need to format them one by one. So the screenshot number 2 would be that 3 disks added for software SAN. So let's take screenshot number 2. Screenshot number 2 would be 3 disks added to software SAN. Well, we haven't configured the software SAN yet, but for software SAN it is being added. 3 disks added to software SAN. So this will be our screenshot number 2 now. I'll take that sample screenshot. Three disks added to software SAN. Screenshot number 2. So screenshot 2, 3, disks added to software SAN, and base screenshot to 3 disks added to software SAN in WhatsApp. Okay, so screenshot 2 is this. 3 disks added to software SAN, so take a screenshot of this, and hopefully you're putting the name there as well. Okay, Dylan says, can you go back to the screen? Oh yeah, so this is the one. So take that screenshot, guys, screenshot 2. Okay, so screenshot 2 is this, and 3 disks added to software SAN. I'm going to just press OK here now, and now we need to format the disks one by one and give them the names there, LON01, LON02, LON03, right? So I'll just minimize this here and command prompt. So I'm just going to go for formatting the 3 disks. So in server 1, I'll go for tools, right? And computer management. And in the computer management, then I'm going to go for disk management. So here the 3 disks are showing, and I'll just drag them up a little and more. Okay, and they're all offline. So disk 1 offline, disk 2 offline, disk 3 offline. So I'm going to go for disk 1 here and right click and put it online. Then there is a second disk I'm going to bring online, and then there is third disk that I'm going to bring online. So in that case, now I'm going to initialize the 3 disks so they could be partitioned as well. So I'm just going to right click here and initialize. When I initialize after bringing all 3 disks online, so they are initialized in one go. So I'm going to click initialize disk. So that's where they are showing. So MBR or GPT, quit partition table or master boot record. MBR is having a limitation of a maximum of 2 terabyte disk, while quit partition table can go for more 64 terabyte disks up to that, or even more. And more partitions and bigger partitions are supported with GPT. So it doesn't apply to us right now. Whichever we select, I'll just stick to MBR. And disk 1, 2, 3 is there. I'm just going to press OK. So now it needs to be formatted one by one. So I'm going to go for disk 1 and right click here, and we can create mirrored or RAID 5 volume because there are 3 disks, but we're going to go for the top new simple volume. Each disk is a separate independent disk. So I'm going to click the new simple volume and click next. So it's the full 400 GB, and then I'll click next here, E drive, and I'll click next. So this will be named as LON01 and perform a quick format. So okay, so there is a screenshot on disk 0. So Hamid, do you have any other disk C drive showing? Maybe it's disk 4 or 3, then it's also okay. Sometimes the numbering is wrong here. It's not wrong, it just gives that numbering there. So there's a screenshot here, guys, and I'm just talking about this screenshot here. So you should just go down, just scroll down here and check. I think you should be able to see your disk there, right? So it might show there, and if it is showing as C drive correct, then it's okay. So if I cancel out from here, so I can see disk 0, you don't see that, but you might have disk 4 here. If you scroll down further, might see here in this area, right? Because I can see that disk up there, C, right? So just click that and you should be able to see that. But yes, the numbering is a bit strange, although it does work that way as well. Don't have simple volume. No, I don't have new simple volume option. Okay, so did you initialize that already? Oh, let me check that again. Yes, you did. Online. And one is, oh no, yes, you have to see this. You have to click here, not click here. This is not the area. You have to click in the unallocated space area and right click here. Then you will see the new simple volume. Okay, now I got it. Now I get it. Yeah, I looked. So hopefully you got it. You have to click here. You're actually clicking on this area. So here, now you see new simple volume when you click on the unallocated space, right? Well, okay, so here new simple volume, and I'll go for next, and then this 400 GB, and I'm gonna click next here. It's just the next available drive letter, which is okay, and next. So there is that LON 0 or LON 01. LON 01 is the first disk. Now it's not yet shared over the network, so that is not we're just naming it that way, but it's not LON yet because it's not shared over the network yet. It will be. So I'm going to click next and finish it. So it's just a local disk that is named LON 01, right? And it's formatting and it's done. So I'm going to go for second and just do the same thing. Right click here on the unallocated space, then click new simple volume, and then click next. That's it. Next, right? It's going to take the drive letter F, and next we're going to go for LON 02 as the label for that. If you forgot it here, you can later rename it as well. And next, I'll click finish for this one as well, then third one as well, and right click here and new simple volume, and click, yeah, so you know the drill now. So it's the drive letter next available is G, next, and LON 03, so, and quick format, next and finish. Okay, so first says are LONs and shared disk over a network the same thing? Yes, exactly, they are the same thing. Okay, right now they are not LONs, they are just named as LONs, they are just local disks for now, but now we're going to convert them one by one to Iscsi. So first of all, I want to see those disks in the this file explorer, the yellow folder. So if I click this PC, so you can see that now LON 01, LON 02, LON 03 or EFG drives are created there, but these are just local disks for now, and we're going to convert them to Iscsi. So let's do that. We'll be converting them to Iscsi, so I'm just going to minimize that and minimize this one as well. What we need to do next is that we need to go to Server Manager here. We need to install the Iscsi feature in Server Manager, and then we're going to convert each disk to Iscsi disk, and then we will be able to share them over the network. So I'm going to go down here to File and Storage Services, because I want to install, although I can install the service from dashboard and arrows and features, but first let's just go to File and Storage Services here on Server 1, and here you can see at the bottom one up is Iscsi already, but that's just the name added here. The background service is still not there. We're about to install that, but I'm going to click that Iscsi here, and as soon as you click the Iscsi, you can see that to install Iscsi target server, start the add roles and features wizard. So the benefit of coming here and then installing is that once we click this link, it's going to open the add remove roles there, or add roles and features, but it's going to be exactly taking us to that area, and that box. It's going to select the box for us as well, the Iscsi server box. So let's click that to install Iscsi target server, and now it is on exactly this roles page first of all, and second thing, it expanded the file and storage services here, then it also expanded file and Iscsi services, and if we go further down, the one option that we want to select is Iscsi target server. So this option has to be selected. It's actually inside the roles here, and this has to be selected, which is already done for us. So I'm going to click next and install this feature. Without this feature installed, obviously you cannot convert local disks to Iscsi disks. So I'm just going to click next here and just go ahead next. And if there's a pending restart, it will restart, otherwise it will not restart. I'm just going to click that and press yes. So restart the destination server automatically if required. I'm going to click install now. Okay, so feature installation succeeded on server 1, file and storage services, file and Iscsi services. So it's installed, and I'm going to click the close button. So Iscsi service is installed. Now we're going to convert each disk one by one convert them to Iscsi disks, and I'm going to click close. Now we need to still remember that terminology here. If we go back to the diagram, that we are right now preparing our target, right? So this is the target. The target is not actually destination in this case. Target is the source, or from where the disks are being shared over the network. So we're preparing the target side first, then we're going to go for initiators, which are actually the destinations. So initiators, both of these will be requesting the disks over the network. So let's configure the target, which is just setting up the disks to be available over the network. Okay, so we're here, Iscsi, and then to create an Iscsi virtual disk, start the new Iscsi virtual disk wizard. So I'm going to click that link here, and it's going to start that. Okay, which local disk you want to convert to Iscsi disk. So these are just all local disks. Obviously the C drive we cannot touch because it has the operating system on it, while E, F, G were the ones that were supposed to be converted to Iscsi. So I'm just going to select the first one, which is E, and we can only select one at a time and go through the wizard. So select E, and I'm going to click next. So it says that, oh, you want to give this disk any name, so we'll keep that naming consistent and go for 101 here and click next. So here, do you want to use the whole size of the disk, 400 GB, when you're sharing it over the network? So yes, we can use the whole size. You can use half of the size, or whatever size you want to use out of 400 GB. And do you want to make this as fixed disk? Fixed disks are thick provisioned, are the same thing. Fixed disk in Microsoft language and thick provisioned in VMware. It's more better in performance, but it takes all this space. It expects all this space to be available in underlying physical disk as well. Dynamically expanding or thin provision is going to save your space, but it's not that good in performance, right? So we're gonna stick with the dynamically expanding, and we're gonna give 400 GB and click next. Now it says that, hey, you want to give a name to the target. So target is this machine that is offering the disks over the network. So we need to name this target as well. So I'm going to click, so it's already selected here, new Iscsi target. I'm going to click next. So the target name could be actually anything, target 1, right? It could be anything there. So once that target 1 is created, I'm going to click next. Now it says that, okay, so who are the initiators? What is the DNS name or the IP address of the initiators in your network? So I'm gonna click the add button because now we know that initiators are server 4 and server 5. So we can put their IP address, we can put their DNS name, we can put their MAC addresses, any way that you want to identify them over the network. So in order to add the initiators who will be requesting the disks, so I'm going to click add button here, and here, so it says that how do you want me to discover those initiators. So we can go down to this, enter a value for the selected type, where we just really want to give an identifying information for the initiators here. So there is an IQN, which is the storage address of each machine. Then there is a DNS name, so server4.yourdomain.local, or IP address or MAC address. So we're going to go for the easiest one or the quickest one as well, which is IP address. So make sure that type is IP address here, and then I'm going to go for 192.168.200.4. So this is the IP here of this machine. Sometimes when I was doing these labs, I gave different IP as well. So, well, that's just the LAN IP is, yes, 4 here, and obviously this one would be 5. In IT, normally we never assume. We just need to see it, and unless you're very experienced and advanced, and so okay, this is 205 and this is 200.4. I'm going to go back to server 1 here, and yes, this is 192.168.204. So sometimes students do a mistake here. Okay, so there's another. Okay, could you go back, please? So, can you show me? Okay, show me from where? 3 steps. Okay, so previous. So I selected the. Okay. Yeah. So here, E drive I selected, and then I clicked next. Then there is, I put there the name as lon01. The name is lon01, and then I click next. So I put the name here as, or number here as 400. Yeah, I want to use the whole disk 400, and it's dynamically expanding. And then, so dynamic expanding is already selected there, just put 400 and click next. After that, then we went for, there's nothing else to choose, it's just like that. So new Iscsi target, and we click next to that. Here you have to give the target name, which is target 1, or any name we can give here. Once that name is given, then we click next, and now we were clicking add button here. So I'm going to click add button, and this is the initiators that we need to tell, which is server 4 and 5. So once you click the add button here, so this is, we can give DNS name, but let's give IP address here, and make sure that the IP address mistake is not done. Very few students actually do that. Suppose you put here 193 and 169, so obviously then you won't be able to make a connection over the network of this disk. So 192.168.200.4, right? So 200.4 and IP address 192.168.200.4. So I'm just gonna press OK. Once this initiator is added, only this initiator over the network can request this particular disk E drive, right? And this is good security feature as well, that whichever initiators IP addresses are added, only they can request, not any random machine can request this. So then we can go for the add button here and go down to IP address again, and then we go for the IP address of the second one, 192.168.200.5. This IP address must be correct, otherwise we're gonna have issues. You won't be able to connect the disks over the network, so nothing else will work as well in failover clustering. So 192.168.200.5, and I'm gonna go ahead and press OK here as well. So the two initiators we have, or we could have had in a big environment 200 initiators, so all those IP addresses of 200 machines could have been here. So whichever machines are allowed to request the disks over the network, their IP addresses or DNS names or MAC address or IQN, the storage name, can be added here. Now once we have added the correct IPs of the two, server 4 and server 5, then we click next. So there's that enable CHAP and enable reverse CHAP. So CHAP is Challenge Handshake Authentication Protocol, and that is an extra security layer. When the target, the one that offers the disk, is offering the disk to the initiators, then it can pop up with whatever username you want to put here and the password, whatever you want to put the password here. So when target is offering the disk over the network, then the CHAP protocol can simply ask that, okay, who is this, and whatever username you define here can be placed there. Then reverse CHAP is when the requesters are actually offering or requesting the disk, so reverse CHAP can be or the password from their side can be put whatever you put here. So this is just an extra layer of security. Normally if obviously this is inside your secure network that you're configuring this SAN, so it's kind of annoying always when this keeps on popping up. Sometimes it doesn't take the username password no matter how many times you put there correctly. And the third thing is the password that you mentioned here is open text, so the sniffers can actually grab that password as well. But this is just an extra layer of security. According to some company compliance policies, suppose they say that any security in the application has to be implemented. So yes, then you can implement. So we don't need to implement, but we understand that when the disks are being offered or disks being requested, at that time, whatever username password you put here can pop up as an extra layer of security. So we don't have to put anything here and click next. Now guys, this is where the target has been defined and target 1, and initiators have been defined, the two initiators, and LUN 1 has been shared over the network. And so this is screenshot number 3 now. Screenshot number 3 would be target and initiators defined, because there are two more disks, right? So for those two disks, we don't need to create a new target and give them the same initiators. Once you define a target and initiators, that is just done once. The other disks keeps getting added to this target. So target 1, suppose you add, we're gonna add 2 more disks, right? So total 3 disks under this target. Suppose it's a big organization, you add here 1,000 disks. 1,000 disks you keep on adding under this target. So whichever initiator connects over the network to this target will get all 1,000 disks that are under this target 1. We just have 3. You're going to see that the initiators will see 3 disks over the network connecting to them. But if you add 5 disks, 10 more disks, 100 more disks, when initiator refreshes, it can also see 100 more disks connected to it, available for it. So the target just has disks with it. to offer, and we can always add or remove disks under the target, from under the target, right? So okay, this is screenshot number 3, that target and initiators defined. So screenshot number 3, target and initiators defined. Screenshot number 3. I'm just gonna take a sample screenshot now. Target is just one, right? Target and initiators defined. That's the label of the screenshot. What kind of cluster roles we can add? Like any application there. If you're talking about the application on top of this, we can add SQL, we can add DHCP even, we can add web servers and print servers and file servers on top of that as well, which is an upcoming topic as well once we configure the FailoverCluster. So here, let's take a screenshot. So target and initiators defined. So I'm just gonna take that screenshot and let's go ahead. I'll go to screenshot 3. Target and initiators defined. Database screenshot 3, target and initiators defined. Okay, so if you go back, so this is a screenshot, guys. This is a screenshot, and I'm going to click create now, and hopefully you're putting your name there in the screenshot. I'm going to click create here now, and so it's going to create that target and initiator. That you have to define only once, and then keep on adding disks after that. So I'm going to click close here, and what we see here is that Iscsi and the one disk that was a local disk is now available. It's going to be available over the network. You're going to see that later. So I need to add the other 2 disks to this target one as well. And how do I add? So I can go to top right here and go to tasks and click new Iscsi virtual disk, or I can just do the same here, right click and new Iscsi virtual disk. So I'm just gonna go to new Iscsi virtual disk, and that same screen opens, and we know the drill. But the good thing is now when we select the F drive and then later G drive, so we don't have to define a target and initiators. That has been once defined. We just add this disk to the existing target. So I'm going to select that F drive and click next. It's going to ask for the drive name, so I'll go for 102 as we've been giving that name before, and click next. So we go for full space, 400 GB. We're going to use the whole of it, and we're going to save some space. Performance right now is not our priority. In production environment, obviously performance is the priority. So dynamically expanding is selected, 400 is selected here, and I'll click next, and target. So we're gonna add this second disk and the third disk to the existing Iscsi target, right? So I'm gonna click next, and that's it. So it's just added to the existing target and initiators, which is good. And I'm gonna click create. Then I'm going to add the third one as well. Or if you had 5, 10, 20, 100 disks as well, so you could have added this way to the same target. So initiators, when they request, they will get all whatever disks have been attached here. We're going to add the third disk here to the same target. I'm going to right click here and new Iscsi virtual disk, and G drive, and then click next. Okay, here 103. We know the drill now. And click next. 400. And click next. So there's that existing Iscsi target here. Target 1, yes, existing, no change here, and click next and finish or create. So we're creating now and close. So we got the 3 disks added to the target, and the target is pretty much ready now. So if we go back to the diagram here, so the target is configured already. With the we added the 3 local disks, we added the Iscsi feature, and then we created a target and defined the initiators, and then added the 3 disks under that target or target 1. Now it's the turn of the initiators to actually request those 3 disks over the network. Now remember one more thing, that we formatted the disks when we newly added these 3 disks to server 1. What happens when the server 4 and 5 will be adding those disks over the network? What will happen is it will be new disks for them as well. So what happens on the initiator side, any one initiator to which you select or map the disk the first time, that initiator will have to format the disks again. For them, it is like you have gone to the market and you have purchased totally new disks and attached it to their server. So when over the network through Iscsi protocol, the disks are added to server 4 or server 5, whichever first time. So the first time you have to again format all the disks. So bring them online, all 3, initialize all 3, and format them one by one. So any one target, any one initiator needs to do that. So we're going to attach those disks first to server 4, but we can attach it to 5 as well. We're just going to go for 4. After that, the 4 has to format all the disks, but then 5 will not have to format those disks, because these are this is the exact same disk that is going to be attached to 4. When 4 formats it already, this is the exact same disk that's going to be attached to 5. So 5 doesn't have to format it. Suppose you had 200 hypervisors here. So the whichever first hypervisor gets these disks over the network has to format it. All other 199 hypervisors will simply add the same disk to each, and they don't have to format that disk. So that has to be understood. I'm going to see that now firsthand, that we're going to map it to 4, and we're going to format all 3 disks again. But when we map it to 5, you just have to bring them online, and they will be 5 will find it all formatted. So I'm just going to go ahead with 4. So let's go to the initiator number 4, which is going to request the disk first. So I'll go to initiator number 4. It has logged out again. I'm just gonna send Control-Alt-Delete here, and small MC, capital MC, 3. Gotcha. Oops. Whatever. It started already now. So small MC, 3. Gotcha. 3. So the server 4 is the first initiator that's going to request the disks now over the network, right? So I closed every other window here. Now how to request the disks from the target over the network. So on server 4, I'm on server manager here. Inside the server manager, on the right side there are tools here, and under the tools this Iscsi initiator link is there, and that is what helps the initiators actually request disks over the network. And this service is normally disabled, so we're going to click it. It's going to say, oh, you want to enable this service, and then it's going to enable that service, and then it's going to let us connect. But before that, we just must make sure that the firewalls are off, because that would be one of the reasons that you won't be able to see those disks properly connected. So I'm checking the firewalls here. I know they're off just to give it more importance because sometimes when you're repeating the lab, then it's skipped. Oh, it is on server 5, so I'll just turn it off here. So I would have received an error here. Okay, turn off. Okay, so again I'm gonna go back to the server 4. That's the first initiator. I'll close that firewall here, and I'll go to tools here, and I'm gonna go down to Iscsi initiator. I'm gonna click that, and it says, oh, you want to turn it on? Yes, I want to turn on this service now, so I'm just gonna press yes. So then it's going to open that window where I can actually configure. There it is. I can configure that initiator. So what we need is through this window to connect or map the 3 disks or LANs over the network. So the target is being asked here, and we know that the target is server 1, and we can give that IP address of server 1. So 192.168.200.1. So that's the 192.168.200.1, right? So we're gonna make quick connect, and we should be seeing, once you click the quick connect, what you should be seeing is this, that this is the storage name, and it says status should be saying connected, and progress report should be saying login succeeded, right? So this is this means that yes, this initiator was able to make a connection to the target. So I'm going to click the done button here. That's not the only configuration that we need to do. The other configuration on the same window is this volumes and devices. So first is target, and you put the IP of the target and click the quick connect here. And the second is that you can go for volumes and devices. So once we go to the volumes and devices, there all you need to do is, since you made the connection in the first tab here in the targets, all you need to do is click the auto configure, and you should, if there are 3 disks, there should be 3 lines appearing there, which are just storage links over the network. I'm going to click the auto configure, and I see that there are 3 lines, and this is in the storage language. It's saying that okay, I'm connected over the network to 3 disks right now. Suppose there were 200 disks there, they would see 200 lines here showing. And so if the auto configure is also done, so target is done and volumes and devices through that auto configure is done. If both are done and showing exactly the same, then we're good. So the 3 disks discovered, initiator connected to 3 disks, 3 LANs. So we can say that too, initiator connected to 3 LANs. So that would be our screenshot number 4. Initiator connected to 3 LANs would be the title. Screenshot number 4 here. Screenshot number 4. Initiator connected to 3 LANs. Screenshot number 4 now. I'm going to take that screenshot number 4 sample now. Initiator connected to 3 LANs. So that's our screenshot number 4. I'll put it on screenshot 4, initiator connected to 3 LANs. And I'll put it in WhatsApp. database screenshot for did 2-3 months. Okay, so I'll go back. So this is a screenshot that needs to be taken, and I'll just go ahead and now press OK here. So that now the 3 disks are added here, but as we discussed in the diagram as well, that once the 3 disks are added to server 4, it's the first initiator that is connected to the disk, so over the network, so it needs to format that. If it was the server 5 that would have been the first initiator, it would have formatted the disk, and the other initiators don't have to do that because it's the exact same disk that is being attached to 4 and 5. So anyone has to do the format. So I'll go back here and check out that, hey, we got the disks. Where are they? So on the initiator that received the 3 disks over the network all once, so I'm just going to go for tools and the disk, the computer management, and then disk management. Why? Because it will exactly look like as if you've added the 3 disks locally, physical disks locally to this virtual machine or physical server. So I'm going to go to, I'm still on server 4, and tools and computer management, and then the disk management. So once we go to the disk management, this server normally has just one disk C drive locally. So if I go to this server 4 and go to the settings to see what are the local disks here, how many, so we can see that there's just one local disk here, 200 GB, right? But once we are inside the disk management, we see actually there are 3 more disks here which are not physically showing there for that particular machine, but they are still available here because they are connected over the network or mapped over the network. So my first disk is still that same with an operating system here. The second, third, or disk 0 is that, and disk 1, 2, 3. Now I'm going to format that. It seems like as if they are local disks, but they are over the network connected. I'm going to right click on disk 1 and online, make it online. Then I'm going to go for disk 2, just like we did before in server 1. We were adding them as local disks, and then disk 3 also online. So they're not initialized, but once you put them all online, then right click on any one of them to initialize all 3 together. So I'm going to click initialize disk, and disk 1 to 3, either it's on MBR or GPT, doesn't matter here, and I'm going to press OK. So all 3 are now initialized as well, and then we're going to format them one by one again, just like we did in server 1. But these are new disks for server 4, so server 4 will, the first initiator will format them one by one, just like we did before. So new simple volume here. The only difference is that these are mapped over the network now. So the first one, new simple volume, next 400 GB. Then again, it's gonna take the E drive here in server 4 over the network as a drive letter within this server 4, and we'll keep the naming also consistent. 101 is the first disk. Next and finish, right? Then I'm going to go for the second disk, and I'll exactly do the same thing. New simple volume, EFG will be here as well, and then next 400 GB, next F drive it will take, next. So then it will go for 102, finish, and we go for the third one now. You know the drill here. New simple volume. Okay. Yeah, next. RGB next, G drive next, and this will be LON03. Next and finish, right? So the first initiator had to format the newly mapped over the network disks, but the second initiator will find these disks formatted already. But the only thing second initiator needs to do, second, third, fourth, fifth, sixth, if we had that many initiators, they will all have to just bring the disks online when they make that connection over the network to the target. So these are the same disks that are in server 4, these are the exact same disks that's going to be on server 5, or any number of next initiators. So I'm going to go up there to server 5, and it's again locked out. So let me see, shift 2, 3, not shift 2, 3, enter. So now this server 5, the second initiator will also first make a connection to the target, and we need to attach the disks. So we know the tool now in the server, and that is Iscsi initiator in server 5 as well. Yes, it needs to be running, so it's gonna activate that. And then we know what to do here. We have to put the IP of the target. 192.168.1, because the target is server 1 that is offering the disks over the network. So if all the communication is okay between this and server 1, so I'm going to click connect, and the file says here, how do you get to Iscsi initiator properties? So we have to, any initiator, you go to tools and you go to Iscsi initiator. So once you click that, so it opens with all its properties here. Okay, so I'll click server 5 here, and so it's yes connected and login succeeded. I'm going to click done here as well, and once it's connected, we need to go to volumes and devices as well, and then we're going to click the auto configure here as well, so it should detect the 3 disks are there, or whatever number of disks you put there, it's going to detect that number of disks here. And so it's going to click auto configure, and yes, 3 ones are showing over the network, or the mapped disks path are showing over the network in the storage language. So if I go up, and I'll just press OK here as well. So these had the same disks have been added to the second initiator, and what we need to still do is we need to still go for tools and computer management. Why? Because we need to at least bring those disks online, and that's all we need to do, because formatting was done by the first initiator already. So second and onwards, all initiators don't have to format those same disks that they're connecting to. So I'm going to click computer management here, and then disk management, and if we expand the screen and put them up here, so you can see that the disks are actually formatted already, 3 disks, but they're just offline. So they were newly mapped to the second initiator, so we just need to bring them online, and that's all we need to do. We don't have to format them. It's the exact same disks on 4 and 5, so already formatted. So once we bring online, they are just simply healthy and formatted. I'm just going to right click here and online, and then I'm going to right click here and online. So LON 1, 2, and 3 are connected, or they're mapped to both the initiator number 4, which is server 4, and second initiator, which is server 05. So if we check our software SAN connectivity, so yes, we're good now. and we have here the three disks are now showing in server 4 and 5. Are they? So let's check that out as well. So if we go to server, we're on server 5, and we can go to the File Explorer here, the yellow folder, and this PC. So the three disks are showing there that are actually mapped over the network from server 1. And if I go to server 4 here and cancel out from here, so I'm going to go for File Explorer and this PC. Yes, the three disks are showing here as well. So the same disk that is in server 1 as E drive is also the same disk here as E drive as well. So once this software SAN is configured, then the failover clustering feature needs to be installed, and that feature will check our configurations of storage and networking, and it's going to mark us for that, like it's 100% correct configuration or is it not correct configuration, right? So I'll just if we go to the diagram here, so our next step now is to actually deploy the feature, the failover clustering. So for that feature we had to go through networking and add a second network card, HP network card, give it 10.0.0.1 and 2, and configure the DNS of that, and then we have to configure the whole software SAN, the target and initiators. Why? For this service. So FC, or failover cluster service, right? And on top of that, obviously we had to do all that for SQL Server. So FC or failover cluster, that needs to be installed in both. So what we're going to do is that we're going to install this failover cluster service one by one on both. So failover cluster has to be, it's a feature actually that needs to be deployed here on both. And once that feature is deployed, then there will be a long test that's going to do. It's going to keep on testing all the nick and corners of these configuration, and then it will tell you, hey, your machines are ready for failover clustering or not. So okay, let's install the failover cluster feature in server 4 and in server 5. So I'll go back here, server 4. Okay, so here we go for dashboard, and in the dashboard we're gonna go for, so I'm on server 4, I'm in the dashboard there, and I'm gonna go for add roles and features, right? So once you click the add roles and features and click next, next, next until you reach the roles window. So I'm just gonna click next, next, yes, that's the name, next. So we're on the roles window, actually the failover feature, right? It's a feature, it's not a role, so we need to still click one more next, and so that feature should be here. Cluster? Yikes, I think I missed it. Oh yeah, this one. So failover clustering. So I'm just gonna select that. It's gonna pop up with, you wanna add some more features that will help. So I'll click add features. So yes, this failover clustering is what we need to select on both the servers. So I'm gonna just select it and next, next, finish, right? So I'll click next, restart if it needs, otherwise it won't. So I'm just gonna select that. If there's a pending restart, it will decide. Then install. So while it's installing, I'm going to do the exact same thing on the other initiator. Suppose we had 12 machines there that are taking part in the failover clustering process, so you have to install it on all 12 machines. I'm on the second initiator here, or server 5, and I'll go for the same process here, dashboard, click add roles and features, next, role based or feature based, next. Server 5, next. And it's not in the roles, it's in the features area. Select failover clustering exactly, and then next install. Start the destination, yes, and install. Okay, so it is succeeded, and I'll just click close here. So the failover clustering feature is now installed on both. Okay, so it is installed on both here machines. So we need to start that and initiate a kind of long test here. It's not very long, but it's gonna really vigorously check each and every corner of this configuration before it tells us, okay, now you're ready to create a failover cluster. So it's gonna check both machines. It's gonna, in fact, try to failover the disks as well. It's gonna do all that in the background. In fact, it's gonna be written there as well. So we're gonna start or initiate the failover clustering cluster feature configuration from any one of the initiators. So it could be server 4. So I'm just going to go for server 4 and check out that if this feature has been installed. So I'm going to click that tools button here, and now I can see that failover cluster manager is showing in, oh, actually it's server 4, 5. So although it can be initiated from any one of the initiators, I'll go for server 4 here and make sure that failover clustering service was fully installed on both. In order to go ahead again, I'm going to go for the failover cluster manager here from server 4, although it can be initiated from any one of the initiators. What can be initiated? The failover clustering evaluation. So it's going to do an evaluation now. So now this failover cluster manager is initiated from server 4, so I'm just going to right click on top of that, and then we need to go for validate configuration. We could have gone for create cluster, but this will also say that, hey, did you validate your configuration? Are these two machines really ready to be part of the cluster? So that's why it's going to validate first. So I'm going to click the validate configuration here and then click next. So it's saying that, okay, tell me the names of the machines that are taking part in this failover cluster evaluation. So I'm going to click browse here and put the names of the two machines that are taking part in this failover clustering evaluation. Okay, where's that? Oh crap. Okay, it just vanished, so I'm just going to click validate configuration, next, and browse. Really? So it is actually not browsing. And also one more thing, guys, I'm gonna go to server 1. I think I have an internet connection here enabled. That is not going to be good for by name configuration. So whichever machine has internet connection, we need to disable that. I'll go to server 1. I'm on server 1 now, and I'll go for the second NIC here, and I'll disable the internet connection in server 1. and I'm going to actually check that in server 2 as well if my internet connection is disabled here. I don't have an internet connection on server 4, and if I go local, yes, it's just local network cards, so only server 1 had internet connection. And I'll just put here, whenever you make a DNS related changes, ipconfig flush DNS, so / ipconfig flush DNS, right? Oh, okay, you got the same. So I'll just go for ipconfig register DNS here on server 1. Okay, and the flush. I'm going to go for server 4 and also just run these two DNS commands here as well. ipconfig / flush DNS, ipconfig / register DNS. And since we're on it on 2 machines, why not on the 3rd one as well? Flush DNS, up arrow, register DNS, and an internet connection on server 1, but have the same results. Oh, okay. Ouch. So yeah, we can just go for this ipconfig flush and register, and I'll just try again after running that if there's an issue. So I'm just going to close this failover clustering now. I'm going to close this, and I'll go again and go down to failover cluster manager, open it, and go for validate configuration again, and next and browse. Oh, actually it still is doing that, so this means that okay, I'm going to try I'm going to restart this machine. Before that, I'll just try the server 5 as well, because you can initiate that from anywhere. So I'll go for tools and failover cluster manager here, and validate configuration, next. Oh, it's happening here as well. Ouch. So I'm just gonna go right click, restart server 4. I'll go inside and restart, shut down or sign out, restart. Restart. It may be that if there's some bug in the window and it needs some Windows updates, that might not be a very good thing, but okay, so yeah, you know, these services right now, these services were not up. What are the services? Actually, these services may not be really connected. They do slowly come up, and there as well they do slowly come up. So I'll just go ahead, and now the browse function may be related to this one as well. So if this still doesn't work, then we can just restart the server 1 as well. Right now, if I go ahead and go to FailoverCluster Manager on server 4 again, there's a validation configuration down here as well. Wow, really? You're kidding me? It's just vanishing. So it could be that the cluster, connect to cluster. So, well, we can right click and go to create cluster directly, but that's going to also be asking, okay, instead of browse, if we can also give the server names here. Actually, this is still going to be a validation here. I'm just going to cancel out. I need to validate it first. So if for some weird reason, if the browse is not working, we can try to put the name here directly. And names of what? Which machines are taking part in the failover clustering process. So it's the machine number 4. What's the name of that machine? If I go to that machine number 4 here, it's server 4. So I'm going to click that computer name here to grab the fully qualified domain name of this machine. And I'll go here and put it there, and I'll click the add button. So it first checks it, and it's actually adding that, so that's a good sign. I'll go for machine number 5 and go to local server and grab the fully qualified domain name from there as well. And go back to server 4, and machine number 5's fully qualified domain name is this. It's going to confirm obviously with the DNS in server 1, and if it finds it, then it's okay. So if it doesn't browse for that, is very weird. Now these machines are not fully updated with Windows updates, so it could be a bug that later might be resolved with some new updates. So, but this is what we wanted. The two machines needs to be validated, and the two machine names need to be here, and they are here now. So whichever machine you have installed failover clustering feature, those machines need to be added here for validation. I'll click next now, and it says run all tests recommended or run only tests I select. So it is run all tests recommended. I'm going to click next now, and this would be a long one. So at the end of it would be the screenshot coming once the tests are passed, hopefully. So what are the tests? These go really down to the storage, the networking, the hardware type, the software type, and it's failing over. It's gonna configure. It's gonna check all in the background. So this is it. I'm gonna start the test now, and in fact we can take a break as well. I'll click that next, and it has started the testing now. So guys, let's take a break. At the end of this test, that screen, we're going to take a screenshot of that screen when it's ended. So right now we can just go ahead and take that break and then come back for the rest of the screenshots. Mute. Okay, so we're back from the break. There is that comment here. Oh, I had an internet connection on server 1 but have the same result. Oh, that's not good. No, like Hamid, did you put that name there? Oh, I think that's an older message, I guess. 51. Oh, okay, sorry. I thought that was a new message. So I'll just go ahead and okay, so there's that validation result here, and I got that yellow triangle instead of a full green uh, here. So now here, server 4 validated, server 5 validated. It says here, and there's a success, but the thing is that it does say this yellow triangle. Now, this view report is the best way to check that what exactly is having a warning, what exact configuration is the warning. But if I go down further, well, actually, I'm just going to click the view report. Once we click the view report, and the report can be opened in IE, Internet Explorer, okay, and I'll make that report big. So, and I'll click that allow blocked content by the, okay. So this is the report that actually shows that inventory is success, network is warning, storage is success, and system configuration is success as well. We can check about the network warning if it is something that we can actually avoid. So I'm just going to click that or ignore. So I'm just going to click the network, and it takes me to the network area where it says validate IP configuration. That has a warning. I want to see further that what is that IP configuration validation that it is giving me warning on. So I'm just going to click validate IP configuration further. So it takes me further down to the IP configuration area, and local connection 2 1. Okay, so normally it's supposed to give me some warning here. Validate that IP addresses are unique and subnets configured correctly. So the first one, actually, local area connection 2, is having this 169 IP, and then there is adapter name. Now that is on server 4. I'm just going to check. I'm on server 4, so I'll just check that how many network cards I have and what's the issue here. Well, I have 2, and HB is supposed to be unidentified and LAN is supposed to be this. So my network cards are okay as far as the configuration is concerned. And adapter this, LAN, HB. So it does detect that there's a third adapter here, which I don't have. So how come it's detecting that? I'll just click my configurations. Yes, I have just 2 adapters here, and adapter 2 is on VMnet 17, and on server 4 I'm going to check the 2 adapter settings on server 5 as well, 15 and 17, and I'll go for server 5 and check it out there as well. Yeah, 15 and 17, so we're okay. So main thing I was saying there, that sometimes the warnings are there, but they can be ignored as well. So I'll just go ahead and go up the level here, so it's back to the top, it says, and on the top this is what it's showing, and in inventory it's all green, green, green. So in IP network, I'll just check again the validate IP configuration, and then it says that, hey, make sure that you have the correct configuration of IP addresses. So it seems like it's okay. Oh, okay, that's where it says node server 4 does not have an adapter usable by the cluster with the defined default gateway. Okay, so it's just saying that where is your default gateway? It's just saying that. So if I go to server 1, and although we don't have a gateway device in our network, but we can actually put our default gateway here for just 192.168.200.1. So I'm just on first machine, and I'm putting a default gateway here. If that's its requirement, I can just go for. Okay, so go to the end of the page. How it says 826. right? And then it says the DNS suffix search lists do not match for all nodes or is unconfigured for some nodes, and scroll to that page. Oh, okay. So well, I saw that now, and before that I saw my area, but I'm just gonna visit that too. So first of all, I'll just put the gateway on all of those. Server 3, although this error is not, and then the DNS suffix search lists do not match for all nodes or is unconfigured for some nodes. DNS suffix search list, okay, so we're gonna check that out as well. First I'll just try to give the gateway here to all the nodes, LAN IP only, LAN NIC only, so I could get rid of the gateway error. So it's not error, it's warning. So 200.1 I'm giving to server 4, which is the IP of server 1 actually, or it could be any other imaginary gateway as well. So to the LAN network card properties, I'm giving the gateway, right? So it's 192.168.200.1 here as well. So I've given the gateway, which is actually a fake gateway, so we don't have any gateway device, but it needs some IP in the gateway. Okay, so 021, no, okay. So Khalid has created a nice diagram which I only can see. Anyway, here I'll just go for server 4 and then check out the other one, that is the DNS suffix search list do not match all. So I'll try to go for this. So verify that the DNS suffix search order exists and is consistent between machines, verifying that there are no duplicate IP addresses. Well, so these are the two things that I see as repairable, and we can actually DNS suffix search list. So that I'm just gonna check my network cards for this setting. Normally, so we disabled that setting for the HP, right? So if I go to network card properties and IPv4 and advanced layer for the DNS, and there's a DNS suffix for this connection. It's showing append the DNS suffix. So we did disable that in the DNS of this suffix, but this was for the heartbeat network card. If I go for LAN, because it can only detect LAN, actually it can detect both. So I'll just check my configuration for the LAN of server 4. I'm checking the configuration. So there's register this connection's address in DNS and DNS suffix for this connection. So well, it's okay actually. We can ignore that, the DNS suffix, and it should let us still create it should let us still create the cluster now. I'll click the back to top. Normally what happens is that we can also run that validation again, and it will take like 15-20 minutes, 15 minutes, and then the validation should be okay, because if we leave any warnings here, then the rest of the configuration is also very sensitive. It might have some issues later. So to save time, I was trying to not put that configuration there. Like validation, I could just skip it as well. So well, this is the results, and testing has completed for tests you selected. You should review the warnings in the report. A cluster solution is supported by Microsoft only if you run all cluster validation tests and all tests succeed with or without warnings. So some of the warnings are okay and we can create a cluster, and some of the warnings are actually not okay. Although I'm not planning to run it again, but I did do what it told me to do, the network, and I put a gateway there. So guys, this would be screenshot number 5, and screenshot number 5 is validation completed for FC. Validation completed for FC. So this is a screenshot number 5. Screenshot number 5. Validation completed for FC failover cluster. So screenshot number 5, let's take it. I'll take that sample screenshot now. Screenshot 5 is validation succeeded for FC. Validation succeeded for FC, so I'm just gonna put that and go for screenshot 5 validation succeeded for FC, and I'll put that screenshot here. Then I'll go for database equals screenshot 5 validation succeeded for FC. I'll put that on WhatsApp as well. And the screenshot page is actually this one. So we took a screenshot of this page and the title is there. So if you have taken the screenshot, I'm just going to go ahead now. Normally this report has to be saved for future purposes, that it's going to really be useful to know that how did you configure and what kind of errors or warnings were there. So on this page I clicked the view report and then we took a screenshot of the view report. Now I'm going to click the create the cluster now using the validated nodes. So I'm just going to go ahead with create the cluster now using the validated nodes. So when I select that, it's going to let me create a cluster. Hopefully everything goes well from here. So I'm just going to select this and click the finish button. So the next wizard will start. That will help us create a failover cluster. After that, we're going to try to switch over and from 4 to 5, making any of the one server active at any given time. I'm going to click that finish now after selecting this. Create the cluster now using the validated nodes. So once we click finish, so the next wizard starts here, and that's going to be the failover cluster creation wizard. So I'm just going to click the next. It just says that, hey, you want to create a cluster, so why don't you put a cluster name here? So we can go for your first name cluster here, and it says that since you're creating a cluster, you need to create or put a separate IP there as well within your network. Whatever is next available IP, you can just put it there. So I'm going to put there 10. I'm sure that within our network we haven't used 10 IP till now, so yes, we have to set aside an IP, static IP here for the cluster service. And once the IP is there and the name is there, I'm going to click next. So the cluster service tries to, if everything goes well, it tries to detect the DNS, the Active Directory, and then it tries to detect the storage as well. You know, the 3 disks, the 3 LONs that we mapped to server 4 and 5, it's going to detect that too. So add all eligible storage to the cluster. So it's saying that, I'm saying yes. So it is already selected. I'll click next now. So if all goes well, it should be successful in creating a cluster. So it says that you have successfully completed the create cluster wizard. So it is successfully done. Now you have successfully completed the create cluster wizard is, well, a good sign. So it has detected node and disk majority here, and that is the quorum that it detected. So now the cluster is successfully created. There's a screenshot number 6 here. Cluster successfully created. Screenshot number 6. Take a screenshot number 6 now. Cluster successfully created. So this is your screenshot number 6. Cluster successfully created. I'm going to take that sample screenshot now. Cluster successfully created. and I'll put it there. So screenshot 7 cluster successfully created. Cluster successfully created. Okay. So this is a screenshot, actually not this one. Yeah, this is a screenshot we took. Oh, sorry, 6, it's not 7. Yikes. Yeah, my bad. So it's, I'll just put it as here, screenshot 6. And I'll correct it on OneNote. Okay. So screenshot 6 here, and I'll just go ahead and just click the finish button, and now screenshot. Now the cluster is created here. That actually is a combination of 2 machines, or 2 FailoverCluster machines. Obviously, minimum 2 are required. So one more thing here is that that current host server. This current host server is whatever server is showing here is the active server. So it doesn't say here active server, but current host server here means this is the active one. If I open the same FailoverCluster manager there on server 5 now, okay, so FailoverCluster manager, and if I select the cluster, so it should also say, so it also says 4. So server 5 says 4. This means it also detects that 4 is the active one and the other one is a passive. So if I go to the 4 and check here, it also says 4. So the FailoverCluster is created and it has detected its active and passive node automatically. I'm on 4 and inside FailoverCluster manager, and I'll expand that FailoverCluster, and then it goes for all the roles here, nodes, how many nodes are there. So once you see the roles inside FailoverCluster manager and the newly created cluster under that, so there are no roles here, right? What is roles? Roles here means what application you want to put on top of this FailoverCluster to make it highly available. So we didn't put any application here, right? So it says here, so whichever server you install and configure FailoverCluster first gets to be the active server. No, it could have been, suppose we were all doing this, so half of the class would have been having server 5 as active and other half would have been having server 4. So no, it's its own internal algorithms that are running and working, and they can choose any one of those. So it's not necessarily where I start first, it could have been other as well. You're welcome. Okay, so here roles means that what application you want to put on top of the cluster that needs to be highly available, right? You can put here web server, you can put here print server, you can put here even DHCP server, and we intend to put here SQL server. So if we go to nodes, so it says that okay, server 4 and server 5 are the 2 nodes and they're up assigned vote and current vote. So this is node majority and vote majority. We have discussed that before in actually the Exchange server class, and just a brief overview of that is this diagram that I created there, and this applies for SQL Server lab as well, because that's the main concept is about the quorum. That is exactly the same everywhere in IT. suppose these were both Linux machines, it would still have been same. So I'll just put this diagram as difference between node and vote majority. And this screenshot we took in SQL Server class as well, but the concept is exactly the same here. So here it's just Exchange server. So, but basically we're going for FailoverCluster here. So it could be any server here. Suppose it's the SQL server, or it's the file server, or any. If a majority of servers are up, then cluster services will stay up. So briefly, I'm just going to go there. If there are odd number of nodes, 1, 3, 5, 7, 9, or even number of nodes, 2, 4, 6, 8, odd number of nodes can decide if they lost the majority. If they lose the majority, then what happens is that the cluster services really stops all the clients and client connections there. But if you don't lose the majority, then cluster services keeps the connection coming for the clients and application to the databases. So in odd number of servers, it's always easy to decide if we have the majority or if we lost the majority, right? If 2 are down and 3 are up, it's a clear majority up. If 3 are down, 2 are up, so it's a clear majority that is down. If majority is lost, the whole services stop. Even though we have 2 servers still up, but we lost the majority, right? In even number of nodes, then it's 1 vote is given to all FailoverCluster servers, and 1 vote is given to a non-FailoverCluster server as well, which is also called witness directory, and that is, or witness disk as well. So in our case now here, in Exchange server we created a witness directory. Here actually, let me show you in storage. If I go to storage and go to disks, so we have a disk witness in quorum. It automatically decides one of the 3 disks. We have 3, right? So minimum we should have 2. One for the data that we need to place on the disk, and one it's going to always make a disk witness in quorum. Disk witness in quorum is just that witness who's going to keep an eye on the active and passive machines. If active goes down, this disk witness is going to wake up the passive machine. Hey passive, you're it now, you're the active one. So if this disk witness is not there, we cannot fail over automatically from active to passive if the disaster strikes. So if we go back here, if there are even number of servers, so FailoverCluster feature cannot actually decide which one, if we have a clear majority or not. So for it to decide, each node is just a machine that takes part in failover clustering. Each node is given 1 vote, and 1 vote is given to a witness directory, right? So that is not a failover clustering machine. So in that case, that if 3 nodes are up and 3 are down, so it's not a clear majority. So 1 vote is taken from the witness directory, and the failover clustering service is fooled into thinking that, oh, we still have majority, and it does not take down all the services and all the end user connections coming to these servers. So if that machine or one more machine goes down, then there's a clear majority of machines that are down, so the whole cluster services are shut down in that case. So that's what the concept of disk witness quorum or witness directory is, that it's going to keep an eye on and tell that when there's a majority and when we lost the majority. So right now, if you see the nodes, you can see that there's assigned vote is current vote 1 vote given to server 4, 1 vote given to server 5. Why the votes are given? Because we have even number of nodes, right? Okay, that's the nodes, and they're up. And second thing is we have disks here, and 3 disks are detected here, but 2 can be used for saving data, while 1 is automatically converted into a disk witness in quorum, and its main job, it's a very critical job that this disk is doing. This disk is not actually inside this server 4 and 5, right? This is living in server 1, and server 1 is not a failover cluster server. So from there it is doing the witnessing, which is the active machine, which is the passive machine. And if the active goes down, the passive it fails over to passive, and passive becomes active. Because of this witness, the automatic failover will happen, right? Okay, so this is the full failover cluster, and then there are networks. So it detects two networks here. Cluster 1, if I select, this is 192.168 network. Cluster network 2, if it detects, then it is 10.0.0.0.8/8 network, right? So that's what we configured. The heartbeat network is 10.0.0, and the actual LAN network is 192.168.200 here. So we get the idea that okay, so other than roles being defined, so the nodes are defined, storage is defined, and we can also see that if we select the cluster here on the top, we can also see that which one is the active node for now. It is current host server 4. If we go to server 5 and in the Failover Cluster Manager, it also shows that server 4 is the current active node. But we need to check if this node is if we can fail over, if we can switch over, right? So we can just simply do that test by right clicking on the your first name cluster here, and then go to more actions, right? So on any of the node, we can go for node is that server that is taking part in the failover cluster process, right? So I'm on server 4, Failover Cluster Manager. I'm right clicking on the cluster name here, and I'm going to more actions, and here I can see move core cluster resources to best possible node or select node. So this means I'm trying to do a switch over, right? I want to switch the active node from server 4 to server 5. So in that case, best possible node obviously is the other node. We just have to, or select node, we will have to select that other one anyway. I'm going to go for best possible node. So if I click that, now current host server or the active server is server 5, and active server is that server that takes end user connections, right? So it's changed here, but did it change here as well? So I'm just going to click server 5, and yes, here also current host is now 5. So that's the active one, and okay, so there was no activity, so it was, I need to really remove that. It's just locking me out. So I'm just gonna go to server 5, and I'm gonna go to power options here and remove that lockout time of 15 minutes or 10 minutes. So I'm gonna go to power options for server 5 and then server 4 as well. I'll go to change settings that are currently unavailable. So, and then I'll go for high performance, make this machine, virtual machine high performance, and change plan settings. So I really need to change that 15 minutes because I have to put a password after every 15 minutes. I'll go for never. So don't turn off the display. Turning off display locks the machine. Then I have to put a password again. So save change, done here. I'm going to go for server 4 and do the same thing. Right click and go to power options. Go for change settings, make it high performance, change plan settings, then change settings again until it lets me change the 15 minutes to never. Click save changes and close this. Okay, so it's not going to lock out now, at least these two machines. And okay, server 1 is going to lock out as well. So I'll just quickly do this here, power options, change settings, best performance. Oh, it's already on never. That's good. Okay, so we understand now that we can failover easily, and server 4 and server 5 both see exactly the same node. So I'm gonna fail back, and you can do it from server 5 or server 4 anywhere. And I'll right click again, go to more actions, and move core cluster resources again to best possible node. So it's going to go back to server 4 again. It doesn't really matter which one is active, anyone has to be active, that's it. So best possible node, and it again shows me in server 5 that server 4 is active now. If I go to server 4, yes, server 4 is active. That done, confirmed. Then if we go back to the diagram, so we have not only installed the failover cluster, but we have also a failover cluster feature we have installed on both, but we have configured our failover cluster. So I would just try to make it as this, that on top of this now there's a failover cluster feature, failover cluster feature in, so that's a failover cluster already created on top of the two nodes. And this failover cluster feature is actually so if I go back here, so we actually gave a name and an IP to this, 100.10. We gave an IP to this, so it's a service that is not attached to any one hardware, but it still has an IP of its own. Normally the applications connect to the failover cluster, and the failover cluster has the information that currently which node is the active one, and it sends the traffic to that node which is currently active. So that's why it has an IP as well. Now we created all this for the application to be highly available. So on top of all this needs to be installed a SQL server, right? So this SQL server needs to be installed. Actually, the SQL server will be installed. Whatever application you want to make highly available has to be deployed on all the participating nodes or all the participating failover cluster servers. So if there were 200 failover cluster servers here, then SQL server, it needs to be installed on all 200 servers, right? It could then fail over to any of the other servers. So we need to install SQL server, but that needs to be done also very carefully. So that's our next step, that we're going to install the SQL server. And now I have my own, obviously, screenshots here as well, where I have put this all configurations. So obviously if you lose even one step, that's it, then you are it becomes a problem. So we will be installing one SQL server here, but how do we install SQL server on server 4, and how do we install SQL server on server 5? So there's a different way to do that, and I'm just gonna try to show that within the screenshots as well. So obviously .NET Framework 4.7 has to be deployed on both, and then I'll just go for so we need to give internet connection to both server 4 and 5, and that internet, once the internet connection is there, then first node has to be installed as and choose SQL server cluster installation. So we're going to install it in a specific way as well. It's not going to be the regular installation now. So once .NET Framework is installed, then start SQL Wizard on server 4 and choose new SQL Server cluster installation, right? So, and that is in the installation area, add node to a cluster installation, and there's a new SQL Server failover cluster installation. Before, when we installed it in new SQL Server standalone installation. Now we need to install it as a failover cluster installation. This type of installation is going to detect underlying failover cluster configurations. But if we install a standalone one, obviously it's not going to detect that there's a failover cluster. It's not going to be able to take benefit of the whole underlying failover or high availability configuration. So I'll just quickly go for .NET Framework, which should be in my machine for server 4 and server 5. I'll just go for the diagram here, and oops, not this one, this one. So on this, obviously the SQL server has to be installed, and also there is SQL server, and before that there should be .NET Framework. So that and also there should be internet connection for the .NET framework to be fully installed. So internet should be on both servers as well. So I'm going to enable internet on server 4 and 5, and by adding a third network card, and temporarily I'll just enable the internet on both and install the .NET framework. And so I'll just go to this server 4 here, minimize this, and on server 4 right click on settings. I'm just going to add the third network card, which is connected to NAT and will give me internet connection, because SQL Server also checks online. So I'll click the add button to add a third network card on server 4 and third network card on server 5 to give it .NET connection, to give it internet connection. So I'll select the network adapter on server 4 and click finish. It's already on NAT, so that's good enough. I'll press OK on server 4 after adding a third network card with NAT. Wow, it's thinking. Okay, it's added here on server 4. I'll go for server 5 and try to do the same thing. Add a third network card with NAT. Select network card, finish, and OK. So while this is still figuring out how connecting, I'll just check that where did I put in this server the .NET framework. This is it. NDP 471 file. I'll go back and copy this in downloads folder of server 4. Oh, it's already there. And in download folder, I think I then installed it already. Server 4, and double click that. Yes, it is .NET Framework 4.7. I press yes. Oh, so I'll check it out then if it's already copied. Maybe it's installed as well, so I don't need to install that. I'll go to server 4, dashboard, add rows and features, next. No, it's not installed. It's copied. Okay. So it's your installation will not occur. Failover the .NET 4.7 later update is already installed. So it's not showing there, but it says already installed. So that's good. And so this means that it is installed here as well. And it's going to tell me that. I'll just let it detect that. So this means I can just directly start installation of SQL Server. And first machine has to be installed, have to have SQL Server, and then the second machine. So while the second machine is still detecting if there's a .NET Framework 4.7 there, so I'll go for the first machine and start the installation of SQL Server. itself. So we actually don't need that. So okay, give the internet connection, and then we're going to go for new SQL Server cluster installation. So I'm just going to attach that SQL Server ISO to the server 4 now, the DVD of server 4. So I'll go for right click and settings, and then CD DVD here. I need to just give the path of the SQL Server 29 GB. Okay. SQL Server is attached. So now we cannot install simultaneously SQL Server on second machine, because first has to be fully installed and the second will be added as a second node or second FailoverCluster SQL. So it has to detect the first one, and the first one has to be fully installed first, right? So on server 4, I have attached that SQL Server already, the ISO to the DVD of this virtual machine, and here it is in the server 4. I see mapped to the DVD. I'll just double click that, and yes. Okay, so that's the first page here, planning, and then there's a installation as well. In the installation, we can see that we were using standalone till now. So there's management tools, server data tools, which is the newer version of management tools. But here is new SQL Server Failover cluster installation. So launch a wizard to install a single node SQL Server 2016, and then you can see that add a node to a SQL Server Failover cluster. Launch a wizard to add a node to an existing SQL Server 2016 Failover cluster. So these are the two links that we need to use once we have configured the underlying failover clustering feature. So I'm going to go for new SQL Server Failover cluster installation here, and once we click that, so product key is evaluation, and I'm going to click next. I accept the license terms. Next. Rule check, Microsoft update to check for updates. Yes, that's the usual next, right? And once we click the next here, so it should detect the underlying configuration. So I'll just drag these screenshots on my other screen to confirm if any small difference or any small thing missed, then obviously it's always a problem. So we're gonna just go for the it says FailoverCluster service cluster verification warning. So it says failover cluster verification warnings, but if I go down if I just go up here, everything else is okay. Normally this does show here cluster verification warning. If I click the warning here, rule cluster verification warnings, generating a warning, the MSCS cluster has been validated, but there are warnings in the MSCS cluster validation report. Yes, we know that those warnings, or some tests were skipped while running the validation. To continue, run validation from the Windows Cluster Administration tool to ensure that the MSCS cluster validation has been run and that the MSCS cluster validation report does not contain errors. It just says that, hey, we detect that there was a warning. Yes, we know that there was a warning as well. There were no errors, yes, and some warnings out of your own judgment and experience, you can say that they're harmless, or you could just fix those and run that validation test again. So it goes a long way if there's a warning. It just keeps on showing in different applications that are totally dependent on high availability for the underlying cluster. Anyway, it's showing there, and I'll just click next here because it's letting me do that. And then I'll go for database engines, and as soon as I select that, so all three SQL Server application, full text and semantic extractions and data quality services are there. And what we have been putting here, I'll just click and put those click tools, client tools there, and client tools connectivity. So once these are selected, these are what we have selected before as well, and so we have to install that on the local disk here, C drive. But when we create a database, we're going to create that database on the LUNs or the shared disks over the network, right? So that's what we need to do. But when we go for the instance name, we're going to go for the eval or evaluation as instance, but it hasn't arrived there yet. So what we've selected here, I'm going to click next now. Now it's asking that, hey, you want to give a name to this instance. So first of all, what is the network name here? And then we can just say that it is a SQL cluster, or we can give any name. So network name, specify network name for the SQL Server failover cluster. This will be the name used to identify your failover cluster on the network. So it could be GB cluster or SQL cluster. So suppose I go for GB cluster dash your first name. In fact, let's keep it simple, just GB cluster. And we can actually give it a name, and that could be eval or evaluation, right? Or that instance, we can just name it something else other than the default instance. And once that is done, then we're going to go for next. On server 4. So you can see that it's going to go for cluster resource group. It's going to try to detect the cluster resources now. So it says that SQL Server cluster resource group name and SQL Server eval, and there's available storage. The cluster group available storage is reserved by Windows Failover Cluster and cluster group. So it says all that, which is okay, and I'm going to click next here, where it's going to then ask for which cluster disk. Remember that we had 3 disks, but it's showing just 2. One disk obviously is the that disk witness for quorum, and the 2 disks are the data disk. So it's just detecting the 2 LUNs here, or 2 disks over the network, right? So if we see the diagram, so it's just detecting 2 out of 3 here, the 2 data disks, and it's saying that, okay, which one will you use for the SQL? And I can select both, or I can select any one here to be used with SQL. So I suppose I go for both, and cluster disk 1 obviously cannot be used because it's for quorum purpose, disk witness group purpose. So I've selected both here and click next. So here it's just saying that select network resources for your SQL Server failover cluster. So SQL Server also needs to have a unique IP address here, and for that we can just go here and actually type an IP address. For that I need to select this here, the box, and then go ahead and give it a unique IP address. So remember that we gave a separate IP address for the FailoverCluster service. The application that's going to be installed on top of that cluster service needs to also have a separate unique static IP as well. So I'll go for 192.168.200. and whatever IP is available and not being used by any other device can be given dedicatedly to this cluster service. So if I go to the diagram, what we're doing is that we gave an IP to the cluster service, FailoverCluster itself, and then that application on top of it that is being installed also needs to have an IP of its own. So when we connect to this SQL Server application, it will have to be this IP through which we make a SQL Server connection, and then the request will go to the FailoverCluster. FailoverCluster will know that which node currently is the active one and will send the traffic to that node. So if we go back here, so we're giving that IPv4 that, okay, we're giving a static IP, and that's what is supposed to be there. And then we're going to go ahead and it's going to simply ask for the services that need to be run. So with what account name you want to run the services, and so we can just go for the logged in SQL server, your first name SQL admin, and the domain. So I'm just going to click that, and SQL Server agent and database engine service, browse. So your first name SQL, I'll just tab and check name. So it's going to fill up that name, it detects that, and the class password. So and then there is that other one. So first name SQL, press tab, check name. Okay, it detects that, and the class password. So once that is done, we can just click next. It's just asking then for the locally logged in user account like this. So how do you want to log in, and do you want the current logged in user to have full authorization in this SQL server? So I say yes, and click next. And it is now installing all this. So this is the summary. Now screenshot number 7 will be that about to install first node of SQL Server FailoverCluster, or installing first node of SQL Server FailoverCluster. So take a screenshot number 7 here. Screenshot number 7, installing first node of SQL FailoverCluster. So take a screenshot. I'm just going to take a sample screenshot now. Installing first node of SQL FailoverCluster. I'll just name it now. So this is screenshot 7, installing first node of SQL FailoverCluster. Installing first node of SQL FailoverCluster. So I'll go for that screenshot here as well. Screenshot 7. Installing first node of SQL FailoverCluster. So this is the screenshot that we took, and I'll go ahead and click the install button so it could install. So this is well, yeah, that's gonna be the SQL installation now, and the other server needs to wait for that. If I go to the other server, it also says that 4.7 is already installed here, so I'm just gonna close that, and the other server needs to wait for the installation of the SQL server on the first one. It needs to wait for it to be finished. It will not take that long time. So there is an error that is shown here, and Hamid is showing that. So no, I didn't. But where did you see this error? Did it let you not go ahead, or? But yeah, I didn't go to cluster events for this. But if you saw that in your event report, then there might be something wrong with the the way the disks were shared there. So depends on where exactly did you see it. Did you see it in the report, or? So I don't think I have this error. It's not there, but if I check it out, normally there is some errors that do show if I go for cluster events. Yes, I also see that. So if I go for the first one, so does is that a showstopper event, or is it gonna be cluster physical disk resource terminate encountered an error? That should release disk PR failure. Well, this has to be okay. There's one critical. Normally the errors do start reporting when you create a cluster, but showstoppers are those where actually cluster simply stops letting you go ahead. The cluster resource hosting subsystem RHS process was terminated and will be restarted. This is typically associated with cluster health detection and recovery of a resource. Refer to the system event log to determine which resource and resource DLL is causing the issue. So it could be that it's just trying to get the health of a disk, and it could not get the report for the health of the disk back. But when we were configuring and going ahead, so the disk performed okay. Now this is actually a pretty long one, and it started from 9 on server 5. This is the time, I think, when we went for failing over. We tested the failover, right? So in that case, it would then report errors that, hey, where's the disk? So we actually failed over and failed back, right? So it's showing on both server 5 and 4 at 9 and 9:01 only. And after that, there is no new event. So it could happen that when we were doing the failover, then the disk would not be there. It would not be able to check that on server 4 because they are now mapped to server 5. So we can ignore that. Actually, this is okay. But that's a nice pointing that out. It's a good point. Okay, so if I check back there, what's going on? It's nearly completing. when it is done, so there will be one screenshot there. It should finish now. Okay, so it's finished, and so guys, well, okay, let's go for the next one as well, and next one should be the screenshot, not this one. So I'm going to click the close here for the first one, and once it is installed, I'm going to check back on the FailoverCluster and go for roles. So now I can see that there's a SQL Server showing here as a role here, right? So SQL Server first node, FailoverCluster first node has been installed on, well, server 4. I'm going to go for second one and quickly start the deployment of SQL Server there as well. So I'm going to go for this, oh, I didn't attach that SQL Server ISO to the DVD of server 5, so I'll go for settings, so I attach the DVD of SQL Server, and then I'll just quickly try to launch it. It's a pop-up. I'll just click that pop-up here, go for run setup, and yes. And what we are trying to do now is to go for add a node to a SQL Server failover cluster. So it shows that first page here for the second node as well. I'm going to go for the installation here as well and go to add node to a SQL Server. That's first one was new SQL Server failover cluster installation, and the second one is add node to a SQL Server failover cluster. So I'm just going to select that on the second one on top of the failover cluster. It also starts with an evaluation and next. So I accept the terms, next, and yes, use Microsoft updates for future updates. So it's also selecting or checking that Microsoft Cluster Service MSCS cluster verification warning. Yes, we know that there was a warning, but everything else is passed, so it's okay. I'll click next. Now it's saying that it does detect that there's an instance called eval, and the name of this node is server 5, and this is GB cluster is the name here. And so it detects the configurations on server 4 as well from the cluster, and I'm just gonna click next here. So it says that you're going to give an IP address to this. So it already detects that there is that IP here which we gave. So it detects that we gave 11 here, right? And that 11 was the specific separate IP address that we chose. So we don't have to really give another IP here. We're just good. So we can just go ahead and try to go next, because all configurations for the cluster was, or SQL Server related configuration on the cluster were done from the first node. And then it's just asking for the services that needs to be connected. So it does say that database engine and agent service will be from, it detects that correctly, and we can give just a password there. And if we click next to that, then it goes to the final here. I'm gonna go ahead and click install, and let's see if well, it should also get installed in maybe 10 minutes. So we're installing the SQL Server on the second node as well, and then we also need to remove the internet after the installation is done, and we can install the SSMS actually in server 1, because we need to connect from server 1 as a client to that instance. So we need to connect from server 1, very new. So I'm going to go to server 1 and connect. While it is installing here, I need to install the client somewhere, right? So not the client should not be on any of these servers. So I'm just going to go ahead and connect the DVD of SQL Server just to install the client now. In fact, I have that available. If I just double click this, so SSMS, right? So that client also is available on the second machine. Well, yeah, this is SSMS. I need that SSMS or SQL Server Management Studio here to be installed on server 1. So I'll just put it quickly on the yellow folder in the downloads folder here. It's overall, it is all slow now. Why am I putting it in server 1? So I could connect from server 1 to whichever is the active node and the SQL Server. If we go for the diagram here, so the SSMS will be then placed here. To connect to active SQL server. So although the whole machine, it's just the SQL server installation is still going on, and if I launch that SSMS from here, it's going to really slow this down further. So it's nearing the installation. Seems like finishing. Okay, so I can try to launch the SSMS, because that's gonna take time. Okay, so its installation is done on the second machine as well. So second node deployed successfully. Second SQL failover cluster node deployed successfully. Alright guys, so that would be our screenshot number 8. Second SQL failover cluster node deployed successfully. Second SQL failover cluster node deployed successfully. So screenshot number 8. Screenshot number 8. Take a screenshot here. I'll take a screenshot here now. Well, we did not install SQL. Did we install it before? Server 1 SSMS. I typed there. No. We didn't install it on server 1 before. On these new machines. Okay, so screenshot number 8. Second SQL FailoverCluster node deployed successfully. I'll just put that there now. So screenshot 8, second SQL failover cluster node deployed successfully, and screenshot 8, failover cluster node deployed successfully. I'll put it there as well. Okay, so this is a screenshot that we took, and after this I'm just waiting for the SSMS to be deployed there on server 1, the client with which we connect to the SQL server, and we'll try to make a connection to the SQL server over the network. So that's being deployed now. So this is a screenshot we took, screenshot 8. Okay, I think we might need internet connection, so I'll try it. Give it internet connection, the first server 1. Hopefully it gets stored today. Well, it's just crawling a little further. Well, looks like it will be installed on time. So once this is all done, actually I need to go to server 5 and remove the internet connection. So I'll go to local server and just simply go for the Ethernet 2 and disable the internet connection on server 5 because we need some local communication from server 1 to server 4 and 5. The SSMS will connect from server 1 to wherever the active server is right now, active SQL server. So I'll go to server 4 and local server, and I'll just disable the internet connection on both server 4 and 5. And also on server 1, once it is done, I'll just remove the internet connection from there as well. Okay, seems to be done. I don't need to restart. I'll just click close here, and I'll just try to click that local server and remove the internet from this as well. So now I'm just going to launch that SSMS here. I'll type in the search and there's the SSMS. I'll click that. So once it opens, so I need to connect to whichever is the active node. I need to check also which is the active node currently. So I'll go to server 4 and then cluster manager here, and I will click the cluster manager, and it shows me that server 4 is the current active node. So if I go to server 5 and cluster manager here as well, so it actually shows server 5. So I'll close this and open it again so it could update itself with the correct current node. Actually it shows 5 here. Are you kidding me? And it shows 4 here, so I'll refresh. It is 5, okay. So it is 5 on 4 and 5 on 5. So yes, now the correct information is there. So I'm trying to did not load correctly. The problem may have been caused by conversion change or installation extension. You get starting Visual Studio could help resolve. Conditions are okay. So I'll just restart this seriously. Okay. Yeah, time's running out. So well, so guys, the thing is that it's still going on. Like I need to actually first connect to the correct node, and then we also need to create then a database, and that database has to be created on the correct shared disks or LANs, and then we need to check that which node is the one that we need to crash and check it out. So that's going to be still some continuous process. So what we can do is you can just upload all the slides now, and we're going to continue from here. So I'll just preserve this whole configuration because there are some more steps there as well. So go ahead and upload your screenshots now to the Blackboard. I put this diagram here which we have been talking about and updating our concepts with. So go ahead and just upload your screenshots to week 12 here, and we're going to continue exactly from here on next Thursday. Thank you and good night. So we'll try to then finish it at that time. So I'll just simply right click and suspend just here. Thank you. Screenshot 8 doesn't says well, screenshot 8 is this. So you can take the screenshot of this screenshot with your name in the background, because I just closed the machines. Oh, okay. So you have it already. Good. That's nice. Okay, guys. So I'll stop the video here and see you next class. All right. Good night. Thank you. All right. Take care.